Okay, second part to this video then. Hopefully it's just in the playlist and it just goes along with it. Again, these questions are straightforward. It's just an unusual style of questions. So once you've created this paper and you've practiced those that Mr. Patrick's produced, it will be there won't be as sort of a mystery to you anyway. You'll kind of get to grips with what they're asking you to do. Okay, so this one's saying there's a liquid P that has a mass of P grams, so you don't know how many grams it is, it's a letter. A liquid Q that has a mass of Q grams, so you don't know how much these liquids weigh. Liquid R is made up by mixing liquid P and Q together in the ratio of 3:7. Find an expression in terms of P and Q for the mass of 50 litres of R. Okay, so that's what we've got to do. So we know that these would be used to mix up the paint, so whatever they may be, liquids, whatever they are, to make up to 50. So what I want to know is how many litres of each I'm going to have. Okay, so that's what I'm going to do. So this is the same as question one in my respects to start off with. I'm going to divide the 50 litres into the ratio of 3:7. So it's all about one part again. So to find one part, I know that I have 10 parts because we've got 3 and 7. So we've got 10 parts altogether. So I'm going to do 50 divided by 10. So now that one part of this ratio is 5 litres. Okay, that is one part. So the ratio is 3:7. I'm going to times them both by 5. So I need 15 litres of liquid P and I need 35 litres of liquid Q. And we don't know the weight specifically, we just know that the grams is in a letter. So it's going to be 15 litres of P, add 35 litres of Q. So that's the expression, because when I know the weights, oh sorry, I do not put Q. When I know the weights of P and Q, I'll rewrite it here so you can see what it should have looked like. I could substitute them into this and I'll be able to figure it out. Okay, but that's the expression, and an expression is algebraic terms being added, subtracted, multiplied, whatever, but it doesn't have an equals in. Okay, so that's the expression for it. You could put equals 50, okay, you don't need to. Right, so the next one is a percentage question, and it's a way of thinking to go this one. You can use multipliers or be logical. So I'm going to try and be logical with this one. I have A, and that is the area. So I'm going to assume the area is the original area, and I'm going to say that the percentage of that is 100%. That's the original one. Okay, and that is going to be increased by 10% to make B, because it says the area of rectangle B is 10% greater than the rectangle of A. So if A is 100%, B, I'm going to add 10% of that to it. So 10% of 100 is 10%. So the area of B will be 110%. So that's this line dealt with. The next line says the area of C is 10% greater than area of B. So I'm going to add 10% from here on. So 10% of 110% is 11%. Because these percentages they're getting into nowadays, they're sort of bringing them in. So that will be 121% overall. So that's that line dealt with. What percentage is the area of C greater than the rectangle A? Okay, so it's 100, it's gone to 121, so therefore it's increased by 21%. So it's all about the building blocks, and with percentages, we're always thinking about establishing what we've got. So we started 100% as my starting point and try to use that building block. Okay, multipliers would work in this case as well. Okay, so there you are. Hopefully we can fit this all on the same page, just about. So I'm looking at, like, I haven't read the question, but I can see cumulative frequency. I can see it's been done for me. I can see the graph. Okay, I don't have to calculate anything right now. I know I'm just going to be drawing a graph, but let's read the question because you should. The cumulative frequency table gives information about the time in minutes Jane took to go from her home to school each day last term. Keep reading last day each term. It's making my mind go mental, but each day of the last term. So every day of last term. So you can see there was 80 days in total, and she was up to an hour late. All right, we have to plot that information on the cumulative frequency graph. So very straightforward. You circle these first because it's always about the end value. and you plot it with the cumulative frequency. So that's what I'm going to do. It might be a bit of a... the first one's 0, so you'll be able to see that one. So the first coordinate is 10, 0, so that goes there. Next one is 27, so along 20 up 7. Make sure your scale's going up in an accurate thing that you know. So I know these are going up in ones because it's 10 squares for 10, so it's all 1. 30, 20, 40, 64, 50, 74, and 60, 80. Okay? You can connect this with straight lines, and my advice, if you're not good at drawing the curve, then draw straight lines. It's very basic, yeah? So it's nice, easy advice. So I'm going to go for a curve. Really proud of myself there. Look how beautiful that looks. You probably use a pencil, but there we go. And using a pencil would mean if your curve is rubbish, then you can rub it out and give it another go. But like I said, straight line segments are fine. Okay, but look how proud I am for that. Look at that. So, that's the graph done. I've got 2 marks there for definite. Jane expects that it would take her X minutes to go from her home to school each day. Okay. 25% of these days, last set, so on 25% of these days, Jane took longer than X minutes to go from her home to school. Okay. Use your cumulative frequency graph to find an estimate for X. So she thinks it normally takes her whatever amount of days, whatever amount of minutes to get to school. She thinks on a quarter of the days she's took longer than this. And the idea is this longer thing, the more than concept. Okay, when you see cumulative frequency, these keywords are about more than. So if we're just doing 25% of the days, okay, we know that 25% is 20 of 80, which happens to be the lower quartile. But we're talking about more than. So instead of doing that, we're going to do it from 60 instead. It's this more than idea. So we're going to go across from 60. I found this ruler in the corridor. So if it's yours, please come see me. Look at that. It's a bit snazzy. It's not very good though because it's a bit flexible. So I'm going to go across from 60 and come down. They're the key ideas of cumulative frequency. These key words just tell you what you're doing. Okay, because it said more than, I knew that. So I'm going for 37. That's what it's close to. So I'm going to go for 37. Okay, so there we go. All right. Now, ideal in an exam, the other teachers and I, we're looking for them to not give you this, for you to actually calculate this and draw this and do a box plot and so on. That's what we hope is going to happen. So cumulative frequency is well worth your revision. So if you weren't too confident while I was doing that, especially with not a great explanation here, I'd say you need to be on must watch, looking at this clip and trying as many examples as possible. Okay. Right, Mark has 18 bags of counters and 12 boxes of counters. The mean number of counters in a 30 bags is 14. The mean number of counters in 18 bags is 10. Work out the mean. The mean. Mark says the mean number of counters per box is 4. Okay. Is Mark right? Mark has 18 bags of counters and 12 boxes of counters. The mean number of counters in all 30 bags and boxes is 14. The mean number of counters in 18 bags is 10. So, altogether, we know that whatever it's in, bags or boxes, the mean number of counters is 14, whatever. Okay? We know that the bags have a mean of 10, so we can calculate how many counters that we have in grand total. We can calculate how many counters there are in just the bags, and then we can calculate from that if the mean of the counters in the boxes is going to be 4 or not. When we're given the mean, this is a reverse mean question. Okay, and I want you to think about the mean. Normally, you would add what you've got and you would divide by what is there. That is the standard mean, going that way. But because we're going reverse, because we're going this way, we're likely to multiply, and we are, and then probably take away at some point. That's the idea. We're going to go in reverse. The mean, when you're dealing with a mean, it's all about the total. Doesn't matter which way you're going. In the normal way, you add to find the total. In reverse mean you're going to multiply to find the total. It's all about the totals. So we know that we've got 30 bags and counters that have a mean of 14 counters in each, and that allows us to calculate how many counters there are in total, whatever we've got, bags or boxes, doesn't matter. So I'm going to do 14 times 3, then add the 0. So 10 times 3 is 30. 3 times 4 is 12. That gives me 42. So in total there are 420 counters. That is the grand total. Okay, that's the grand total. We also know we've got 18 bags with a mean of 10 in them. So that means we've got 180 counters in the bags. If I subtract them, I can calculate how many counters are in all these boxes. Okay, so we've got 420, take away 180, so I'm just going to do it basic like that. Cross them out. 0, sorry. Borrow from there. Just doing basic maths really. You can just add them up normally if you want to. Okay. So there are 240 counters in the boxes. So that's how many counters are in these boxes. We know we have 12 boxes. So now we can calculate the mean and see if the mean number of counters in each box is 4. So basically, is there only 4 counters in each of these boxes? Probably unlikely looking at this. So we've got 240 in total. We're doing the normal mean now. So we've already got the total. We're going to divide by how many there. So there are 12 boxes. It's supposed to be divisible. Which means, if we do it this way, I know that's going to be 20. It's easier sometimes to think of it like this. So you can start to break it down. Whichever point you get, you can start to calculate it. Doesn't matter how you break it down, but we're shown that the mean is 20. So he's wrong. Okay, he is wrong. You have to comment. Okay. Right, this one, recurring decimals. This has just got a non-recurring part. That's what's going to put people off. Okay. I'm just going to leg it. It's going to sound really, I'm going to go leg it, get my dinner, so I can do dinner intervention with you guys that are coming now. Okay, so I'll finish this later.